So I have to admit that when I saw that ColdFusion 2018 introduced the concept of futures, I thought to myself, oh, we finally have promises in ColdFusion. Unfortunately, the moment I started digging into futures, I realized that promises and futures are almost nothing alike. I'd say at the very highest level, they both deal with asynchronous control flow, but essentially that's where the similarities end, and then the specifics of each individual abstraction really diverge. But after digging into futures a bunch, I still have this dream that maybe I could make them look and act a little bit more like promises. And in JavaScript, one of the nicest things about promises is the promise constructor, where I can take a function, and that function is invoked with resolve and reject functions, which would then can be used to drive the outcome of the generated promise object. And as a thought experiment, I want to see if I could build this kind of functionality on top of the future implementation in ColdFusion 2018. And I didn't quite get there because there's really a lot of hurdles to get over in the future implementation, but I got something that kind of looks like it. So let's take a quick look at my consuming code before we look at the implementation. So I have inside this utilities file my FutureNew function, and FutureNew is my future constructor, my promise-inspired future constructor. And just right off the bat, you'll see that this whole thing is inside of a try-catch because future errors that are thrown inside of a proxied function can't be caught by the .error callback. Again, just one of the hurdles in trying to make futures look and act like promises. That said, you'll see that I have a FutureNew function here, and FutureNew accepts a callback, and that callback is provided with a resolve and a reject method just like JavaScript. And this FutureNew constructor returns a future, and I'll skip over this for a second, and you can see that I'm taking that future and then I'm binding to the then, and I'm returning another value, and then you can see that I'm just blocking and waiting for that whole value. So essentially the output of this is going to be whatever the FutureNew resolves to plus resolution, and then we're going to get that string. We're just going to write it to the output. So let's take a look at what is happening inside of my FutureNew function callback. So one thing I wanted to demonstrate was just the fact that resolve and reject are actually the things that are driving the outcome of this future. So I'm having a couple of nested run asyncs just so that we know that it's not the return value or the behavior with this function itself that's driving that future. So again, just for demonstration purposes, I have two nested run asyncs inside of this, and inside this triply nested one is really where we get to see the functionality shine. So one thing to note is that internally I'm using an empty future to bridge the gap between these resolve and reject functions and the outcome of the future. And because I'm using that empty function, that empty future, only the first resolve or reject call actually matters. So you can see that I have a number of resolves in a row, and then you can see I'm following those with rejects. And these essentially are all getting ignored. Everything but the first call to the first resolve or the first reject is what determines the outcome. Everything after that is just silently ignored. So right now, if I resolve to so much win, that resolve is going to drive the outcome of this future. Then this then binding is going to hook into that so much win, and we should get resolution so much win. And if we jump over into the browser and we refresh, boom, resolution so much win. Okay, so now let's go in and let's comment this out, and you'll notice that we didn't get any errors or anything that happened at that point that is problematic. But if we go in and comment this out, the next resolve isn't resolving a simple value, it's actually resolving a future. So the resolve is taking the result of this run async. So this run async is going to resolve to inner zen, but it's going to return a future. The FutureNew function is going to be looking for futures and is going to implicitly unwrap them. So instead of having the future chain just pass a future down through, it's going to unwrap this future and try to return its value. So at this point, we should get resolution inner zen. If we go here and refresh, boom, resolution inner zen. Awesome. So now let's go ahead and comment this out, and the next thing we have is a bunch of rejections. Now, unfortunately, error handling in ColdFusion 2018 features is pretty awkward in that none of the details of the error pretty much make it up to the calling context. So in this case, I'm going to reject with such rejection, and my FutureNew is actually going to parlay that into a ColdFusion error. But when we run this, you'll see that none of that information made it back up here in terms of, right, so let's just look for rejection, right? There's no rejection on this page, and that's because the error handling in futures basically swallows and obfuscates all of that information. Now, internally to the FutureNew, because I know that that's happening, I'm actually writing this to the ColdFusion logs. And actually, sorry, I forgot to prepare this. And what we can see here, and let me just clear the screen. Let's start again. Let's refresh. Boom. Here you can see FutureNew error such rejection. So at least I'm logging this to the error logs internally to FutureNew because I know that those error details are not going to be bubbling back up into the calling context. Now, that's when I reject with a simple value. If I want to reject with a structure, then this structure is being used to invoke the throw method, the throw function, and so that's going to try to parlay these it's going to parlay these struct keys into attributes of the throw method. So now, if we do it this time, again, we get no meaningful information here in the error handling because such as ColdFusion error handling with futures, but if we look in the log, you'll see at least now I'm getting message, this is crazy pants, type boom, right, which is what we saw here. Now I can also throw an error, and normally if I threw an error inside of a run async that was inside of a run async that was inside of this would just disappear into the ether. We'd get nothing. And in fact, the only reason that this is capable now is because you'll see down here I'm actually binding to the error of the run async and passing in the reject. So if we do this, so hold on, so this is going to be coming as kablamo. Again, we get no information here that's helpful, but the logs should say it actually dumps the entire error object here, which is, giving us as much information to go on. So I'm probably not even going to be able to find kablamo, but kablamo should be in here somewhere. Let me see if I can demonstrate that. Let's just grab this. And oh, no, kablamo's not in there. Yeah, oh, of course kablamo's not in there, right? Because this is using the actual future error handling, which again sucks. So we don't get any of that information. Now here's what's interesting. If I comment this out, so that essentially we're throwing an error inside of a run async that's inside of a run async that's inside of the FutureNew, we get nothing. So you'll see, you can't really see it, hold on. So the page is just standing here hanging, and it'll eventually time out, right? So it just timed out after 5 seconds. And here we can see we get the task timeout error. And that's because the FutureNew actually has an implicit timeout that you can pass as a second optional argument. But anyway, so let's take this guy out now. And instead of just throwing and catching with the reject, let's throw and then pass that error object explicitly to the reject handler. And let's just get back over here. And if we do that, again, no useful information here in the top level error, but if we jump back over here, you can see that again we're writing that FutureNew error to the error logs, and here we get all of the good information. So like message, boom goes the dynamite, and you can see that was actually the error message. So you sort of have to work around a lot of the error handling in ColdFusion 2018 futures, and hopefully some of that gets improved in the future, no pun intended. But for now, again, there's just a lot of hurdles to jump through. But what you can see is that what I have is something that kind of, sort of, maybe-ish looks like a Promise Constructor if you squint hard enough, and hopefully can maybe lay some building blocks for some more interesting information. There's a lot of information in the implementation of the FutureNew, a lot of code here, and I'll take a quick look at it, but I'll let you sort of look at that on your own. Essentially, it takes a callback. I'm immediately running all of the logic here inside of a run async because essentially we need to do stuff to basically anything you do to a future object turns it from an asynchronous call into a blocking synchronous call. So anytime I do something like add an error or a then or give something a timeout, it turns it into a blocking method. And the whole point of the future is to not be blocking. So in order to not be blocking, I have to wrap all of this logic inside its own run async to keep it asynchronous. Now, once it's asynchronous, what I'm going to be using is an empty future to sort of bridge the gap between the resolve and reject functions and the future that gets returned from this FutureNew constructor. And the resolve and reject methods, as you can see here, all they're doing is turning around and taking that empty future and fulfilling it. And they're either filling it with a struct that has a value or a struct that has an error. Now, I then go ahead and invoke the callback that gets returned or gets passed in. I pass in the resolve and reject. And you can see here inside the then handler for that run async, I'm essentially blocking and waiting until that empty future, that bridge future, is fulfilled. So if you don't fulfill it explicitly, this will just keep sleeping until this run async times out after 5 seconds. Of course, if you do fulfill it, then hopefully that comes through pretty quickly. And at that point, I get the bridge value, which I'm calling here the resolution. You can see if the resolution is an error, then I write it to the log, and then I jump through a couple of hoops to try and parlay the error into an actual ColdFusion error. So I either throw a full detailed struct or a full detailed error. If you gave me a struct, then I'm going to use that struct as the attribute collection on the throw. And if it's not a simple value and it's not a struct, I'm going to assume it's actually a ColdFusion error, and essentially I'm just going to rethrow it. Now, if it's not an error, if it's a value, but the value looks like it's gettable, then I'm going to get that value. So I'm going to implicitly unwrap a future and then return the result of that future. And otherwise, I'm just going to go ahead and return the value here. And you can see that we're then returning the resolution of all of this, which is eventually going to resolve the async wrapper. And yeah, that's a ton of code. I'm going to let you pick through that on your own. But essentially, what it does is allow us to get something that, again, kind of sort of looks like a promise constructor. It takes a callback, that callback accepts a resolve and reject function, and then I can use that resolve and reject function to resolve or reject this future, and again, blam, resolution, so much win. So there are a lot of hurdles here, as you can see, especially with the error handling, maybe even primarily with the error handling. There's a lot of uphill battle you have to do. But I think I was able to get close enough to something that looked like a promise constructor that I'm now, my excitement has been piqued, and I actually kind of want to see if I can take this foundational building block and see what other interesting asynchronous control flow that I can build on top of that. I do get the sense that if you really wanted to build a promise-like abstraction, you could, but it would probably take a full promise implementation, and you'd really have to hide all of the details of the future. But it could be possible. Something in there could be possible. I think it's a little bit, or maybe quite a bit beyond my skill set, my ability at this point. But certainly, I'm very curious at this stage, and I'm still excited to dig into the future implementation in ColdFusion 2018.